Alright, an experiment is the only time that you can demonstrate a cause and effect relationship. So hopefully we'll be looking for a lot of experimental data when we're trying to understand psychological phenomena. There's a lot you'll want to know about how to conduct an experiment. And the first is that you have to have at least two groups. You have to have a control group and an experimental group. When you have a research idea, you need to think about what the cause is and what the potential effect is. So for example, if I think that people who drink caffeine have better memories, that's my hypothesis, let's say, then the cause would be the caffeine, because I think that caffeine will affect memory. Memory is the effect. Memory is what I expect to change. So you have to know those two things. In this example, caffeine is the independent variable. Independent variable just means this is what you expect to cause something to happen. You expect that people who drink caffeine will have better memories. So caffeine is the cause. Your independent variable is the cause. Your dependent variable is the effect. It's what you measure, and it's what you expect to change as a result of your experiment. So again, in this scenario, we're testing the effects of caffeine on memory. Caffeine is the independent variable. Memory is the dependent variable. Let's go back to our two groups. The control group is really important because they are who you're going to use as a comparison. You're going to give a group of people caffeine, but that's the experimental group. The experimental group receives the independent variable. The control group does not. Let me say that again. Experimental group receives the independent variable. The control group does not. That way, when you give both groups the exact same measure, and in this example it's a memory test because memory is our dependent variable, then hopefully you'll see some kind of difference between those two groups. So again, the dependent variable is memory. You're going to give them the same memory test, and if there's a difference between their scores and you've set it up correctly, then you can say, wow, look, caffeine played a role. Caffeine was my independent variable, and it caused an effect on the dependent variable, which is memory. And remember that your experimental group receives the independent variable, control group does not. Now there's a few precautions you have to take when conducting experiments. The first is to make sure that your groups are randomly assigned. In other words, you can't just say, let's put the boys in the control group and the girls in the experimental group, because maybe girls have better memories already than boys. And if there's that huge of a difference between your two groups, then caffeine may or may not be what caused the change in your dependent variable. So you have to use random assignment. Just randomly put people in groups. That's the best way to minimize any kind of differences between them. You also have to make sure that you account for something called the placebo effect. Now this is when a participant's beliefs affects their behavior, affects their physiological symptoms. Placebo effects can be very powerful. So this is why it's really important that your participants don't know if they're in the control group or in the experimental group. Ideally, you wouldn't want to know, in our example, if you had caffeine or not, because your belief about caffeine might actually override its power. So neither of those groups know if they're receiving caffeine or not. That's what we call a single-blind study. And what it means is the participants don't know which group they're in, and that's a good thing. But the best kind of experiment to conduct is a double-blind experiment. The experimenter themselves can also have bias, and they can have expectations that can affect the results of the study. So the best kind to do is double-blind. Double-blind, not only the participants are clueless as to which group they're in, but the experimenter doesn't know either, and that eliminates their bias. So you obviously have to have other people come in and assign folks to groups, collect the data, and keep both participants and experimenter out of the loop. But that's the best way to conduct a study, double-blind. So single-blind only eliminates the placebo effect. Double-blind eliminates both the placebo effect and the experimenter effect. So again, there's a lot to know about the experiment. Make sure you read that material very carefully and work with those practice questions until you can look at an experiment. You can tell me whether it's single-blind or double-blind. You can tell me what the control group is, what the experimental group is, and what the independent and dependent variables are.